In this video, our goal is to build frequency counts for a grayscale image and plot the histogram. We will walk you through 4 exercises to achieve this goal. In exercise 1, our goal is to obtain the frequency count of a specific intensity value or an intensity range. We will use a MATLAB built-in grade level image named tire.tif to practice the skills. Please base on the given image to answer the following 2 questions. Question 1. What is the pixel count frequency for pixel intensity 63? To answer this question, the first step is to import the tire.tif image into MATLAB. Then we can create a variable v to hold the specified intensity value, which is v equals 63. And then we can obtain the frequency for intensity 63 using frequency count equal sum. So as you can see, the frequency count for intensity 63 is 154. Question 2. Assume the entire grade level spectrum 0 to 255 is divided into 64 bins. That is, each bin consists of 4 intensity levels. How many pixels belong to the second bin, bin 2? To answer this question, the first step is to get the lower bound and upper bound for bin 2. The bin 2 intensity range is from 4 to 7, and thus the lower bound is 4 and the upper bound is 7. Based on the lower bound and upper bound for bin 2, we create 2 variables, LB and UB represent lower bound and upper bound respectively. Then we can obtain the frequency for bin 2 with the following statement. So as you can see, the frequency count for bin 2 is 4,384. In exercise 2, our goal is to create a MATLAB function to build image histogram. The structure of a MATLAB function is defined between the function and end. The function header includes return variable in the square bracket, equal sign, function name, and input variable in the parentheses. To create a MATLAB function, you can click New Function. Because a grade level image img is the function input and a vector frequency count is the function output, and thus the structure of the function and its header is the function name is histogram and the input is img. And the green color indicates the programmer's command. Because we need to store the frequency count for each bin, and thus we need to create a return variable, frequency count as a vector, where the number of elements equal to the total number of bins. In this case, we create a vector of 256 zeros. As we have practiced how to obtain the frequency count of a specific intensity value or intensity range in exercise 1, for simplicity, we adopt the solution for question 1 as our base case. So our base case is FREQ count equal sum mg compared with value v. And v we will assign to any number later, for example 63 in our previous case. Okay. However, there is a need to assign each intensity level as a specific intensity value. Therefore, we need to use a loop. On the screen is the structure of a for loop in MATLAB. The loop is defined between the for and end. Two examples are provided to demonstrate the usage. Because a grade level image has 256 different intensity levels, we create a for loop around our base case where the loop variable for end. The loop variable, we call it bin index, represent the which bin. Okay, so the bin index is from 1 to 256. As frequency count is a vector holding frequency counts for all bins, we should store the count to the corresponding element in the vector. So we need to modify the frequency count to frequency counts and provide the bin index. It is worth noticing that the pixel intensity starts at 0 and ends at 255, which is the bin index subtract 1. So we need to replace all the val with bin index subtract 1. To this end, we save this MATLAB function as an M file, where the file name must be identical to the function name. On the screen are two solutions for exercise 2. The difference between the two solutions is that the solution 1, the pixel intensity value is used as a loop variable, and in solution 2, the bin index is used as a loop variable. In exercise 3, our goal is to create a MATLAB script to get a histogram count of a grayscale image and plot its histogram. In this exercise, we will import a color image named handful_gemini.png. As our build histogram only takes grade level image as its input, we need to convert the RGB image to grayscale using RGB to gray. So we can create a script by new script. Okay. First, we load the color image. And we convert the gray level, the color image to gray level using RGB to gray. Then we can pass the gray level image to build histogram function. The frequency count will be returned to the script. Based on the returned frequency counts, we can plot the histogram using bar function, where the first input parameter is the x-axis representing categories, and the second input parameter is the y-axis representing the frequency counts. Before we call the bar function, we need to open the figure window, and we call the bar function. The first is the category, so the intensity level is from 0 to 255, and the second parameter is the frequency counts. We can save the script as exercise 3 and run the script. So you can see the figure window 1 shows the histogram. In exercise 4, we will practice how to use imhist function provided in the MATLAB image processing toolbox. Imhist displays a plot of the histogram of input grayscale image. In this example, we will open a figure window 2 and use imhist to apply on the img. So you can see it's displayed in figure window 2. Alright, thank you for watching. Bye-bye.